February 27, 1945. Elsdorf, Germany. Sergeant Nicholas Maschlonik watched through the periscope of Pershing No. 40 as a Tiger I heavy tank emerged from behind a burning building, its long 88mm gun traversing toward American positions. 4 rapid shots from the Pershing's 90mm gun struck the German heavy tank at 1,000 yards while Maschlonik's vehicle was moving. All 4 rounds penetrated. The Tiger crew abandoned their vehicle. German observers watching from defensive positions 2 kilometers away noted every detail of this engagement in field reports that would reach Wehrmacht intelligence within hours. The Americans had deployed a new heavy tank. Its gun performance matched German 88mm weapons that had dominated European battlefields for 3 years. The reports triggered immediate requests for technical intelligence. What exactly had the Americans finally fielded, and how did it compare to German armor superiority that propaganda had promised would never be challenged? Within weeks, German engineering officers were compiling combat reports, analyzing shell impacts on destroyed German vehicles, and attempting to reconstruct the specifications of this new American threat from fragmentary battlefield evidence. The 90mm gun mounted on the Pershing represented the American answer to a problem that had plagued Sherman tank crews since Normandy. For the first time in the war, American tankers possessed a weapon that could engage German heavy tanks at ranges where German guns could also destroy American vehicles. The technological advantage Germany had maintained through superior firepower was finally being challenged, not through captured enemy equipment or Allied improvisation, but through American industrial engineering that had produced a gun matching German ballistic performance. The recognition among German technical intelligence officers that American 90mm tank guns had achieved parity with German 88mm weapons represented a fundamental strategic shift occurring far too late for Germany to respond. The mathematical reality of armor penetration and engagement ranges that had favored German forces throughout the war was being equalized precisely when Germany lacked the industrial capacity, material resources, or time necessary to maintain technological superiority through further development. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The development of American 90mm anti-tank capability began years before the Pershing entered combat, rooted in lessons learned from North African campaigns, where American forces first encountered German armor in significant numbers. The 90mm gun originated as an anti-aircraft weapon, the M1 model entering service in 1941, designed to engage high-altitude bombers. The gun's 3.5-inch bore diameter and 15-foot barrel length provided ballistic performance exceeding earlier American anti-aircraft weapons. By 1942, American ordnance recognized that the same characteristics making the 90mm effective against aircraft, specifically high muzzle velocity and flat trajectory, would prove equally valuable against armored targets. The Army ground forces demanded a weapon capable of defeating German heavy tanks at safe engagement distances. German 88mm guns, originally anti-aircraft weapons adapted for anti-tank use, demonstrated the viability of this approach. American designers followed similar development paths, adapting anti-aircraft gun technology for ground warfare against armored threats. The M3 variant of the 90mm gun entered production specifically for tank destroyer and tank applications. The weapon measured 52 calibers in length, meaning the barrel extended 52 times the bore diameter, providing sufficient length for complete powder combustion and maximum projectile velocity. The M3 fired several ammunition types, each designed for specific tactical situations. The M82 armor-piercing capped shot became the standard anti-tank round, weighing 24 pounds with a muzzle velocity of 2,650 feet per second. This performance placed the weapon in the same class as the German 88mm Quack 36 liters, 56 mounted on Tiger I heavy tanks. The comparable performance was not accidental but represented deliberate American engineering effort to match demonstrated German capabilities. American ordnance officers studying intelligence reports from European and North African theaters understood precisely what performance levels German guns achieved. The specifications for American 90mm ammunition were written to ensure parity with German weapons that had proven so effective in combat. At 1,000 yards range, the M82 shot could penetrate approximately 151 millimeters of vertical armor plate. This penetration capability exceeded the frontal armor thickness of every German tank except the Tiger II, providing American tank crews with a weapon theoretically capable of defeating most German armor frontally at combat ranges. The theoretical capability mattered less than the practical reality that American tank crews finally possessed a gun with engagement ranges matching German weapons. Sherman crews armed with 75mm guns faced the grim mathematics that their weapons could not reliably penetrate German heavy tank frontal armor at any practical range, while German guns could destroy Shermans at ranges exceeding 2,000 meters. This engagement range differential forced American tactical doctrine emphasizing numerical superiority, maneuver to flanking positions, and acceptance of casualty rates that would have been unacceptable if American weapons had matched German firepower. The M36 tank destroyer, mounting the 90mm M3 gun, entered service in July 1944, providing American forces with mobile anti-tank capability matching German heavy armor. The M36 used the M10 tank destroyer chassis, modified with a new turret accommodating the larger gun. Production reached over 2,000 units by war's end, giving American armored divisions significant numbers of 90mm guns deployed in the anti-tank role. Tank destroyer doctrine called for M36 units to engage German armor from defensive positions or ambush, leveraging their powerful gun while accepting lighter armor protection than tanks carried. Combat reports from Normandy through late 1944 demonstrated that the 90mm gun performed as designed, destroying German Panthers and Tigers when crews achieved hits on vulnerable areas. The gun's effectiveness validated American ordnance decisions to develop this weapon system, even as debates continued about whether the 90mm should be mounted in tanks rather than limiting it to tank destroyers. Army Ground Forces leadership, particularly General Leslie McNair, argued that specialized tank destroyers should engage enemy armor while tanks supported infantry with lighter, more maneuverable vehicles. This doctrine proved increasingly inadequate as combat experience accumulated. Sherman tanks encountered German armor regularly in situations where tank destroyers were not available for support. The doctrinal separation between tanks and tank destroyers created tactical inflexibility, forcing Sherman crews to engage German heavy tanks with weapons inadequate for the task. Casualty rates among Sherman crews reflected this doctrinal failure, as tanks designed for infantry support were forced into armor versus armor combat. They lacked firepower to win on equal terms. The T-26 heavy tank program, which eventually produced the Pershing, emerged from recognition that American tanks needed firepower matching German weapons. Development began in 1942, even as Sherman production reached maximum rates. Multiple prototype variants tested different automotive configurations, transmission designs, and suspension systems. The T-26E3 variant, mounting the 90mm M3 gun in a new heavy tank design, represented the configuration eventually approved for production. The T-26E3 weighed 46 tons in combat configuration, significantly heavier than the 30-ton Sherman, but lighter than German Tiger tanks. The weight increase came primarily from heavier armor protection, with frontal hull armor reaching 102 mm thickness. The 90mm gun provided the firepower American armor commanders had requested since early encounters with German heavy tanks. The combination of adequate armor and powerful gun created a tank theoretically capable of engaging German Panthers and Tigers on equal terms, eliminating the technological disadvantage that had characterized American armor since Normandy. Production delays postponed T-26E3 deployment until the final months of the war. Political opposition from Army Ground Forces leadership, who favored tank destroyer doctrine over heavy tanks, combined with manufacturing priorities for existing Sherman production, prevented earlier fielding. The tank destroyer doctrine McNair championed assumed that specialized anti-tank vehicles could handle German armor, making heavy tanks unnecessary and wasteful of industrial capacity. Combat experience contradicted this doctrine repeatedly, but institutional resistance delayed recognition that tanks needed anti-tank capability equivalent to dedicated tank destroyers. The Battle of the Bulge in December 1944 finally broke through the bureaucratic resistance to heavy tank deployment. German forces committed approximately 400 Panther tanks, plus Tiger II heavy tanks and other armored vehicles in the offensive. American losses to German armor during the battle demonstrated conclusively that existing American tanks lacked firepower to engage German heavy armor effectively. The psychological impact on American tankers who watched their weapons bounce off German armor while German guns destroyed American tanks at ranges, preventing effective return fire, created morale problems that senior commanders could no longer ignore. On December 22, 1944, orders were issued to deploy T-26E3 tanks to Europe immediately. 20 tanks were shipped in the first deployment, arriving at Antwerp, Belgium in January 1945. The tanks were divided between the 3rd and 9th Armoured Divisions, units that had experienced heavy combat and possessed experienced crews capable of effectively employing new equipment. Training emphasized that T-26E3 controls matched Sherman designs in most respects, allowing experienced tank crews to transition to the new vehicle with minimal specialized instruction. The deployment was designated the Zebra Mission, a program introducing multiple new weapons systems to European combat simultaneously. The 90mm gun-equipped tanks were the most significant element, representing American industrial capability finally fielding weapons matching German firepower. Army ordnance officials accompanied the tanks to Europe, prepared to address mechanical problems and collect combat data informing future production. The tanks received the official designation M26 in March 1945 and were named Pershing after General John J. Pershing, commander of American forces in World War I. The first combat engagement occurred February 25, 1945, near the Roar River. The 3rd Armored Division employed Pershings in company with Shermans, testing the new tank's combat performance against German defenses. The 90mm gun proved immediately effective against German fortifications and armor. Crews reported that the weapon's penetration and accuracy exceeded Sherman guns by margins, making tactical engagements fundamentally different. Where Sherman crews had learned to maneuver for flanking shots against German heavy tanks, Pershing crews could engage frontally with confidence. Their gun could penetrate at ranges where German return fire posed significant threat. The engagement at Elsdorf on February 27 demonstrated Pershing capabilities against German heavy armor in conditions approximating the tank versus tank combat that American doctrine had struggled to address ineffectively. Sergeant Mashlonik's destruction of a Tiger I at 1,000 yards while moving represented exactly the combat performance American ordnance had specified when designing the 90mm tank gun. The 4 hits required to destroy the Tiger reflected the reality that even powerful guns needed multiple strikes against heavily armored targets, but the penetration achieved at combat range proved the weapon's effectiveness. German field reports documenting this engagement reached intelligence offices rapidly. Wehrmacht tactical intelligence focused on gathering information about enemy equipment capabilities, analyzing combat performance to inform defensive tactics and strategic assessments. The appearance of American heavy tanks mounting guns with performance matching German 88mm weapons represented significant intelligence requiring immediate analysis and dissemination to field commands facing American armor. German observers noting the engagement recorded details, including the approximate range, the number of hits required for destruction, and the apparent caliber of the American gun based on shell impact damage. These observations, combined with reports from other sectors where Pershings engaged German forces, built a composite picture of American heavy tank capabilities that German intelligence officers found deeply concerning. The Americans had not merely improved existing tanks, but had fielded an entirely new vehicle class, addressing the firepower gap that had given German armor tactical advantage throughout the war. The recognition that American 90mm guns matched German 88mm weapons eliminated assumptions that had shaped German tactical planning. German armor doctrine assumed that Tigers and Panthers could engage American tanks at ranges, preventing effective American return fire, allowing German forces to destroy numerically superior American armor through superior engagement distances. If American guns now matched German weapons in range and penetration, this tactical advantage disappeared. Tank combat would be determined by factors beyond gun performance, including crew training, tactical positioning, numerical superiority, and combined arms coordination, areas where American forces held advantages German commanders recognized but had hoped superior equipment could offset. The mathematical parity between 90mm American guns and 88mm German guns became clear through detailed ballistic analysis German intelligence conducted using all available information. The M82 armor-piercing shot fired by the 90mm M3 gun achieved muzzle velocity of 2,650 feet per second, closely matching the 2,657 feet per second achieved by the German 88mm KGK, 36 firing pacificwar 39 armor-piercing rounds. At 1,000 meters range, both weapons achieved similar penetration against vertical armor, approximately 150mm for the American gun and 148mm for the German weapon. This performance parity meant that in direct combat between a Pershing and a Tiger I, neither vehicle held decisive firepower advantage. Both guns could penetrate the other tank's armor at typical combat ranges, making the engagement outcome dependent on crew skill, tactical position, and which tank achieved first hit. This represented a fundamental shift from earlier American-German tank encounters, where German guns could reliably penetrate American armor, while American guns could not penetrate German armor frontally, giving German tanks overwhelming advantage in direct engagement. German engineering officers, analyzing combat reports from multiple sectors, identified patterns confirming that American 90mm guns represented a systematic capability rather than isolated experimental weapons. Reports from Cologne, where a Pershing destroyed a Panther tank in the Cathedral Square on March 6, provided additional data. Reports from Remagen, where Pershings supported the capture of the Ludendorff Bridge on March 7, demonstrated that American forces were deploying these weapons in tactically significant numbers. By mid-March 1945, German intelligence estimated that American forces had fielded at least 20 Pershing tanks in combat, with more arriving continuously. The intelligence analysis attempted to reconstruct American production capacity and deployment timelines based on the evidence available. German officers recognized that American industrial capability could produce tanks in quantities far exceeding German output. If the Americans had developed a heavy tank matching German firepower and were beginning production at typical American industrial scales, German armor would face numerical and qualitative disadvantages simultaneously. The strategic implications were dire for German forces already struggling with fuel shortages, manufacturing disruptions from Allied bombing, and personnel losses that could not be replaced. The technical assessment of the 90mm gun focused on comparing its performance across multiple parameters to German 88mm weapons. German intelligence had access to extensive data on their own guns' performance, including penetration at various ranges, accuracy characteristics, and ammunition effectiveness against different armor types. The comparison required estimating American ammunition performance based on combat evidence, captured ammunition when available, and technical analysis of shell impacts on destroyed German vehicles. The M82 armor-piercing capped shot represented standard American anti-tank ammunition for the 90mm gun. The 24-pound projectile used armor-piercing cap design similar to German ammunition, with a soft metal cap protecting the hardened penetrator core from shattering on impact with sloped armor. The ballistic cap behind the armor-piercing cap improved aerodynamic performance, maintaining velocity over distance for maximum penetration at extended ranges. This ammunition design philosophy matched German practice, indicating that American ordnance engineers understood the same metallurgical and ballistic principles German designers applied. German technical intelligence noted that while the M82 shot performed comparably to German pacificwar 39 ammunition, American metallurgy appeared inferior to German standards. Shell fragments recovered from battlefield impacts showed steel quality that German metallurgists judged inadequate for optimal penetration performance. The hardness, characteristics, and grain structure suggested that American ammunition would shatter more readily than German rounds when striking armor at oblique angles. This metallurgical deficiency meant that theoretical penetration calculations overstated actual combat effectiveness, particularly against sloped armor designs German tanks employed. However, German analysts recognized that even with inferior metallurgy, American 90mm guns achieved sufficient penetration to threaten all but the heaviest German armor. The Tiger I frontal armor, 80mm to 100mm thick depending on location, could be penetrated by 90mm guns at combat ranges when striking perpendicular to the armor surface. The Panther frontal glacis, 80mm thick at 55 degrees slope, presented a more challenging target, but 90mm guns could still achieve penetration under favorable impact conditions. Most critically, German medium tanks, including late-model Panzer IVs with 80mm frontal armor, had no protection against 90mm guns at any practical combat range. The comparison between the American 90mm M3 gun and the German 88mm KK-43 mounted on Tiger II tanks revealed that American standard ammunition remained inferior to German heavy tank weapons. The Kilo K-43 achieved muzzle velocity of 3,280 feet per second, firing PESGR-43 ammunition, substantially higher than the M82 shot's 2,650 feet per second. This velocity advantage translated directly to superior penetration, with the KK-43 penetrating 219mm of vertical armor at 500 meters compared to 164mm for the 90mm M3. German intelligence officers noted this performance gap with some relief, recognizing that their most advanced tanks retained firepower superiority over standard American heavy tanks. The Tiger II could engage Pershings at ranges where return fire posed minimal threat, maintaining the engagement range advantage that had characterized German armor throughout the war. However, the intelligence analysis also identified American development of improved 90mm ammunition that threatened to eliminate even this advantage. American T-33 armor-piercing ammunition represented improved design with ballistic cap and ray heat-treated steel, providing better penetration characteristics. German intelligence estimated this round achieved muzzle velocity of 2,800 feet per second, penetrating approximately 205mm at 500 meters. This performance approached the KK-43 standard ammunition, reducing the gap to margins that would not provide decisive advantage in combat. More concerning was intelligence regarding American HVAP, high-velocity armor-piercing ammunition, using tungsten carbide cores in subcaliber projectiles. The M304 HVAP round achieved muzzle velocity of 3,340 feet per second, substantially exceeding both German 88mm KJK-36 and even the KJK-43 when firing standard ammunition. Penetration reached 278mm at 500 meters, sufficient to defeat Tiger II frontal armor at combat ranges. This ammunition represented exactly the kind of technological development that could eliminate German armor advantages completely, giving American forces weapons superior to anything Germany fielded. German intelligence officers recognized that HVAP ammunition faced the same production constraints Germany experienced with tungsten-cored ammunition. Tungsten scarcity limited German production of PESGR-40 APCR ammunition, forcing rationing that prevented widespread tactical use. American tungsten resources exceeded German supplies, but American commanders faced similar decisions about allocating scarce materials between competing military requirements. The intelligence assessment concluded that while American HVAP ammunition existed and proved highly effective in testing, battlefield availability would remain limited, preventing it from becoming standard issue replacing conventional ammunition. This assessment proved partially correct. American forces issued HVAP ammunition selectively to units expected to engage heavy German armor, but production constraints prevented universal distribution. Pershing crews often had limited quantities of HVAP rounds, perhaps 5 to 10 rounds per tank, with the remainder of their ammunition load consisting of standard M82 shot. This limitation meant that while American 90mm guns theoretically could penetrate Tiger II armor, practical combat effectiveness depended on ammunition availability at the moment of engagement. The accuracy comparison between American 90mm and German 88mm guns revealed surprising results that complicated German tactical assessments. The M3 gun demonstrated superior accuracy to the KUK-43 when firing HVAP ammunition, with dispersion patterns at 2,000 yards showing tighter groupings than German heavy tank guns achieved. German test data for the KUK-43 showed 90 cm vertical dispersion and 70 cm horizontal dispersion at 2,000 meters range. American 90mm guns firing HVAP achieved approximately 60 cm dispersion in both axes, representing approximately 30% improvement in accuracy. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. This accuracy advantage, combined with HVAP penetration capability, meant that American heavy tanks could engage German armor at extended ranges with reasonable probability of achieving first-round hits. German tactical doctrine had emphasized achieving first-hit advantage through superior optics and crew training. If American guns now matched or exceeded German accuracy while achieving comparable penetration, the first-hit advantage became more random, depending on which crew saw the target first, and achieved firing solution fastest rather than superior equipment providing decisive edge. German intelligence analysis attempted to assess broader implications of American 90mm gun deployment beyond immediate tactical considerations. The strategic question was whether American heavy tank production would reach scales that threatened German defensive capabilities. German forces defending against Allied advances relied heavily on superior tank performance, compensating for numerical inferiority. If American tanks now matched German performance while American production vastly exceeded German output, the mathematical reality of attrition warfare became insurmountable. German tank production in 1945 operated under increasingly severe constraints. Allied strategic bombing had destroyed critical manufacturing facilities, particularly the Maybach engine plant at Friedrichshafen, severely damaged on the night of April 27 to 28, 1944. This single raid destroyed production capacity for Panther and Tiger tank engines, plus ZF transmissions, halting production completely for 6 months. When production resumed in November 1944, quality control had degraded substantially due to reliance on forced labor and material shortages. The comparison of production rates showed the scale of German disadvantage. American factories produced over 2,000 Pershing tanks between November 1944 and the end of 1945, with production ramping up continuously. This output occurred while American factories simultaneously produced thousands of Sherman tanks, M36 tank destroyers, and countless other military vehicles. German production of all tank types combined, including Panthers, Tigers, and tank destroyers, totaled fewer units than American Pershing production alone during the same period. German intelligence officers calculating these production differentials recognized that even if German tanks retained qualitative superiority, which the Pershing's deployment called into question, quantitative disadvantages made defeat inevitable. The Pershing represented American industrial capability, finally addressing the one area where German forces had maintained advantage. With that advantage eliminated, no pathway to German victory existed regardless of tactical skill or defensive preparations. The metallurgical analysis of American ammunition revealed aspects of American industrial philosophy that German engineers found simultaneously inferior and pragmatic. German ammunition manufacturing emphasized precision and metallurgical excellence, producing shells with carefully controlled hardness gradients and optimal material properties. This approach required skilled workers, specialized equipment, and time-consuming manufacturing processes that limited production rates even under ideal conditions. American ammunition manufacturing prioritized production volume over individual shell quality, accepting performance variations that German engineers considered unacceptable. The result was American ammunition that performed adequately rather than optimally, with individual rounds showing wide variation in penetration performance compared to German ammunition's consistency. German test firings of captured American shells revealed that some rounds shattered against armor that should have been penetrable, while other rounds from the same production lot penetrated successfully. This inconsistency troubled German engineers, who valued predictable, reliable performance. However, American tactical doctrine accommodated this variation by emphasizing multiple hits rather than single-shot kills, using ammunition abundance to overcome individual shell unreliability. German forces could not adopt similar approaches because their ammunition scarcity forced careful rationing. German tank crews learned to make every shot count, knowing that ammunition resupply might not arrive for weeks. American crews could fire multiple rounds, achieving kills through volume rather than precision, secure in knowledge that ammunition supply would keep their tanks fully loaded. This philosophical difference reflected broader contrasts between German and American approaches to military technology, with German emphasis on excellence confronting American emphasis on adequacy sustained by industrial abundance. The tactical implications of Pershing deployment forced German armor commanders to revise defensive plans that had assumed American armor could be engaged at ranges preventing effective return fire. German defensive doctrine positioned Panthers and Tigers in hull-down positions, overlooking likely American approach routes, allowing German tanks to engage at maximum effective range while minimizing exposure to return fire. This doctrine worked brilliantly against Shermans with 75mm guns that could not reliably penetrate German armor frontally at any range. Against Pershings with 90mm guns achieving penetration at 1,000 meters or beyond, hull-down positions no longer provided the decisive advantage German tactics required. German commanders recognized they needed to modify tactics to account for American heavy tanks capable of engaging at extended ranges. The revised guidance emphasized ambush positions at closer ranges where German guns retained slight advantages in penetration and could achieve multiple rapid hits before American crews responded. This tactical shift surrendered the engagement range advantage that had been fundamental to German armor doctrine, forcing German tanks into closer engagements where numerical American superiority became more decisive. The psychological impact on German tank crews of facing American armor with guns matching German weapons proved difficult to quantify but significantly affected combat effectiveness. German tankers had grown accustomed to fighting from positions of technical superiority, knowing their guns could destroy enemy tanks at ranges where return fire posed minimal threat. This confidence enabled aggressive tactics and psychological dominance in armor engagements. Facing Pershings eliminated that psychological edge, creating uncertainty about whether German tanks could survive direct engagement with American heavy tanks. German after-action reports from units encountering Pershings documented this psychological shift. Panther commanders who had previously engaged Shermans with confidence reported hesitation when facing tanks mounting 90mm guns. Tiger commanders recognized that while their armor provided protection against Sherman guns, Pershing guns could penetrate Tiger armor at combat ranges, eliminating the invulnerability that had characterized Tiger operations against earlier American armor. This psychological dimension of technological parity undermined German combat effectiveness as surely as the physical threat from American 90mm guns. The intelligence assessment compiled by Wehrmacht technical officers in March and April 1945 painted a grim picture of German armor prospects. The Americans had finally fielded a tank matching German firepower and armor protection. American industrial capacity would produce these tanks in quantities far exceeding anything German industry could manufacture under current conditions. Allied air superiority prevented German armor from maneuvering freely, forcing defensive operations that surrendered initiative to American forces. Fuel shortages immobilized German armor even when mechanically operational, preventing concentration of forces for counterattacks. The 90mm guns' performance matching German 88mm weapons represented the final elimination of German technological advantages. German optical superiority, while still present, could not compensate for American numerical superiority combined with equipment parity. German crew training advantages, developed through years of combat experience, were being lost as experienced crews were killed and replaced with minimally trained personnel. Every factor that had allowed German forces to achieve tactical successes, despite numerical inferiority, was being systematically negated by American material and manpower advantages. The comparison between the Pershing's 90mm M3 gun and German 88mm weapons revealed both the achievement of American ordnance engineers and the limitations they faced working within American industrial and military culture. The M3 gun matched German 88mm KAT-36 performance almost exactly, achieving comparable muzzle velocity, similar penetration at combat ranges, and equivalent accuracy. This parity emerged from deliberate design decisions to match demonstrated German capabilities rather than pursue superior performance that might delay production or increase costs. American engineering philosophy accepted adequate performance available immediately over superior performance, requiring extended development. German engineering philosophy pursued optimal performance regardless of development, time, or production complexity. The Pershing's 90mm gun exemplified American pragmatism, delivering performance matching German weapons using proven technologies and manufacturing methods that could be scaled to mass production. German engineers recognized this approach as inferior to their pursuit of excellence, yet the practical result was American guns matching German weapons deployed in far greater numbers. The development timeline comparison highlighted these philosophical differences. American 90mm gun development began in 1941 as an anti-aircraft weapon and was adapted to anti-tank use by 1942. Tank-mounted variants entered combat by late 1944. This timeline reflected American willingness to deploy weapons as soon as they achieved minimum acceptable performance, rather than pursuing perfection through extended testing. German tank gun development emphasized exhaustive testing and refinement before production, resulting in superior weapons deployed in inadequate quantities. The broader strategic assessment German intelligence provided to Wehrmacht leadership emphasized that the Pershing's deployment represented more than the addition of a new American tank type. It symbolized American industrial capability, finally addressing every German advantage systematically. American air superiority had eliminated German Air Force tactical effectiveness. American artillery superiority provided overwhelming fire support to ground operations. American logistics superiority maintained supply lines supporting sustained operations German forces could not match. Now, American armor parity eliminated the last area where German forces held qualitative advantage. German generals receiving these intelligence assessments recognized that continued resistance could not alter the war's outcome. The mathematical realities of American industrial and manpower superiority, combined with technological parity across all weapon systems, made German defeat inevitable. The question was not whether Germany would lose, but how many additional casualties would occur before the inevitable surrender. The Pershing's 90mm gun, matching German 88mm weapons that had dominated European battlefields for years, represented the final proof that German technological advantages had been systematically eliminated. The tactical intelligence distributed to German units facing American armor included specific guidance for engaging Pershings based on analysis of their capabilities and vulnerabilities. The guidance acknowledged that Pershing frontal armor, 102 mm thick, could be penetrated by German 88mm guns at moderate ranges but required careful aim at vulnerable points. The guidance emphasized targeting the turret ring, lower glacis plate, and driver's vision ports as weak points where penetration probability increased. The guidance warned against assuming that German armor provided protection against Pershing 90mm guns, instructing crews to avoid direct engagement when possible and emphasize ambush tactics. This defensive guidance represented a dramatic shift from earlier German doctrine that had emphasized aggressive armor operations leveraging technical superiority. The new guidance essentially instructed German tank crews to avoid fair fights with American heavy tanks, acknowledging that technical parity combined with American numerical superiority made direct engagement unfavorable. German tanks should engage from ambush, achieve kills rapidly, and withdraw before American numerical superiority could concentrate overwhelming force. This represented the tactics of inferior forces rather than the aggressive doctrine German armor had practiced through most of the war. German tank commanders recognized the implications of defensive guidance, emphasizing ambush over maneuver. German armor doctrine, developed through years of offensive operations, stressed mobility, concentration of force, and aggressive exploitation of breakthrough. Defensive tactics, suited to avoiding engagement with technologically equivalent opponents, contradicted everything German tank forces had trained to execute. The psychological impact of this doctrinal reversal compounded the material challenges German forces faced, undermining the offensive spirit that had characterized German armored operations. The comparison of American and German tank development philosophies revealed fundamental differences in how the two nations approached military technology. Germany pursued technological superiority through engineering excellence, developing weapons with performance exceeding enemy equipment by substantial margins. This approach produced Tigers and Panthers that dominated battlefields when properly employed, but required manufacturing precision and material quality. Germany struggled to maintain under wartime conditions. America pursued technological adequacy through mass production, developing weapons with performance matching enemy equipment while emphasizing reliability, maintainability, and production volume. This approach produced Shermans and Pershings that worked reliably under field conditions and could be manufactured in overwhelming quantities. The Pershing represented American engineering philosophy, achieving its goal. The tank matched German heavy tank firepower through the 90mm gun while providing adequate armor protection and acceptable mobility. The design emphasized reliability over performance, using proven automotive components rather than sophisticated but temperamental German engineering. The result was a tank that worked when needed, could be maintained by normally trained crews, and could be produced at scales German industry could not approach even under ideal conditions. German engineering philosophy produced technically superior individual tanks that suffered from systematic reliability problems and production limitations. The Panther mounted a more powerful gun than the Pershing and featured better armor protection, but broke down frequently and required specialized maintenance German logistics struggled to provide. The Tiger II represented the ultimate expression of German tank design philosophy, mounting the most powerful gun and thickest armor of any production tank, while also suffering from catastrophic reliability problems and production rates so low that most German tank units never saw one. The American approach of adequate performance in overwhelming numbers defeated the German approach of superior performance in inadequate numbers through the simple mathematics of industrial warfare. 1,000 Pershings with guns matching German weapons could accomplish more than 100 Panthers with superior guns, because the Pershings would actually be present on battlefields, while many Panthers sat immobilized by mechanical failures or lacked fuel to move. American logistics kept Pershings supplied with ammunition and fuel, while German logistics failed to keep Panthers operational. American maintenance kept Pershings in combat, while German maintenance struggled to repair complex Panther systems under field conditions. The strategic lesson German intelligence officers derived from analyzing Pershing capabilities extended beyond immediate tactical considerations to fundamental questions about how technological development served military objectives. German emphasis on technical excellence produced impressive weapons that won individual battles while losing campaigns through insufficient numbers and poor reliability. American emphasis on adequate performance produced unimpressive weapons that lost individual battles while winning campaigns through overwhelming numbers and sustained operational capability. The recognition that American 90mm guns matched German 88mm weapons represented the culmination of systematic American effort to eliminate German technological advantages through focused industrial development. American ordnance had identified specific German capabilities, assessed the technical requirements to match those capabilities, and executed development programs delivering weapons, achieving performance parity. This methodical approach lacked the innovative brilliance of German tank development, but proved far more effective strategically. German tank designers pursuing technical excellence created Panthers and Tigers that impressed everyone who saw them and terrified Allied tank crews who faced them. American tank designers pursuing adequate performance created Shermans and Pershings that looked unimpressive compared to German designs, but worked reliably, could be maintained under field conditions, and arrived on battlefields in numbers that made individual technical superiority irrelevant. The contrast between German brilliance and American competence revealed which approach better served the requirements of industrial warfare. The final German intelligence assessment of Pershing capabilities, compiled in April 1945, as American forces advanced into Germany's heartland, acknowledged that American armor had achieved parity with German equipment across all relevant parameters. The 90mm gun matched German 88mm weapons in penetration and accuracy. Pershing armor protection matched Panther frontal armor thickness while exceeding most German medium tanks. American production rates guaranteed that every destroyed Pershing would be replaced, while German losses could not be replaced at all. American logistics ensured that Pershings would remain supplied and operational, while German tanks sat immobilized by lack of fuel and spare parts. The assessment concluded that continued resistance could not alter the war's outcome, but would only increase casualties on both sides. The technological advantages Germany had leveraged to achieve tactical successes, despite numerical inferiority, had been systematically eliminated. American forces now possessed quantitative and qualitative superiority across all combat arms. The recognition among German intelligence officers that American 90mm guns matched German 88mm weapons represented acknowledgement of a larger truth. American industrial capability had finally addressed every German advantage, making continued German resistance militarily futile. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.